Hey, good morning, everybody. This is Mr. Ainsworth here, and we're going to go through the Chapter 9 Selective Response Practice questions to get you guys ready for your second attempt, okay, for the Chapter 9 test. And if you're going to be doing this, then now's the time to do it right, all right? Prepare properly and learn something in the process. So, what you need to do is you're obviously in Canvas here because you got this document here. First thing, though, you need to read this carefully and do it right, okay? First thing is you're going to be doing this on paper. So you click on this link right through here and print it out, get ready, get your Desmos set up, get that ready. And then when you do, and you go through the practice questions here with me, take detailed notes on how to do them, go at your own speed, and then do your best. If you have no cards, like I said, number three here, point number three, then use them instead. I know printing off a piece of paper from what I produced is easier, but if you have no cards, they are better because you can separate them into two groups, ones that you know really well, one that you don't, and you can also randomize it too. I prefer that. That's what I did ever since I was a little kid. They were highly effective as long as you practice them over a period of time. So, which brings me to point number four. You got to practice daily. Going through these questions is not enough. So, if you're thinking that you could just watch this video, take notes on the answers, and then be more successful, you are sadly mistaken. Okay, and you're really misunderstanding what it means to actually prepare properly. After you do this, you need to practice. You need to fold the paper along the vertical and actually practice by redoing the problems. That's called active recall. Then, number five, you got to space it out over time. Your practice sessions should be done daily in between sessions for other classes. And you should also, number six, practice randomly too, which means obviously practice them out of order while you keep track of your mistakes and those that you have difficulty with. Okay. And then if you do that over a course of 5 to 7 days, because that's what you have an entire week, show up on Tuesday on the 19th and you're good to go. All right. And I'm going to even give you 90 minutes just so you can go slow and pay attention to detail. So if you do this, do it correctly and then follow my important points on 4, 5, and 6. Bring this document to class on the Tuesday on the 19th, because if you don't, you're not going to be taking the practice exam or the retake. Okay, so do it right. Okay, so go ahead and let's upload this document into your actually no, you know what? You're not doing it in OneNote. You're doing it on paper here. So let's just get started. So notice that I have the problems on the left-hand side. You got yours on paper here. Questions on the left, your answer solutions on the right. Notice that I have Desmos set up, and if you haven't set up Desmos, well then you better, because if you just copy notes, you're not doing it right. Okay, so let's start doing it right. You got to actively participate, which means you got to have Desmos. So you're going to be pausing and playing and working through the lesson here, going at your own speed. All right, and if I go too fast, well, guess what? It's a video, so just pause, play, and rewind. All right, the iPad can be go 50-50 or a 2-to-1 split. So I don't need the graphing calculator yet. So let's get started. Oh, and we also need a Z table here. Hmm, so we need Z score, Z values, and we also need the probability. We need a Z table for this first one here. So you know what? Before I get started and before you guys get started, you need to get a Z table, and guess what? Print it out. And if you don't uh, have access to that, well, you got to open up your iPad. You have Z tables all over the place. Okay, so let me just grab mine real quick because I just noticed that I forgot to set that up. So notice over here, this is what we do in class, for our lessons. So right there, now we have a Z table. Okay, so let's go ahead and read the problem. Your first selective response problem. So in a lifetime here of new batteries in a flashlight here is normally, or if the lifetime of new batteries in a flashlight is normally distributed, which means everything that we learned in chapter 1 applies. As a mean, right here, a mean of 180, it says so, right there. Right, standard deviation of 10. So notice that I'm writing down what I know. So I have a mean 180 hours, standard deviation of 10 hours, and they guarantee that their batteries will last 185 hours. What percent? Okay, what percent of batteries will meet that standards? That will last at least 185 hours. So I need to find, okay, the percentage of all the batteries that will last at least greater than or equal to 185 hours. Okay, so that's the first thing I do. I write down what I know and I write down what I'm trying to find, right? So here we go. What's the z value for 185 hours? So the first thing you need to do is a z-score is found by taking the score minus the mean divided by sigma. Okay, score minus the mean divided by the standard deviation. Okay, now if you don't have that memorized, again, that should be memorized. And as you practice, you're going to get it between your ears because you need it. These are things that we've been studying for the past 2 months, all the way since chapter 1. Okay, all right, so I need to get a z-score first. So let's do that. So I take my score, which is 185, subtract the mean, 180, divide that by 10. That's 5/10 or 0.5. Okay, so now on the z-table here, I look for 0.5, and 0.5 is the same thing as 0.50. So the hundredths place is 0. So I go across and down, and I read the value. So I find 0.5. So I go to the positive side of the z-table here, and I find 0.5, and there's 0, 0. So I go across and down, and I read the number, 0.6915. So 0.6915, 0.6915. Guess what? That's 69.15%. These are percentages, guys. And the z-table always gives you percentages to the left. So this tells me, so far, I know the percentage of all the batteries that last less than, all right, less than, where was it? 185 hours. That's what I found first. This is what the table gives me. So 69.15%. Now, if you read the problem, it says, what's the z value? Okay, we found that. I found that right here. Again, you do it on the right-hand side because you want to use this as a study tool. Later on, when you solve all these problems, you're going to follow along the vertical and you're going to read the question and actually practice and review these problems. Again, this is the first step. Okay, studying correctly takes a lot of hard work, a lot of grit. Okay, what you need to develop. So keep that in mind. It says, what is the probability that battery will last less than, look at this, less than, that's less than or equal to, excuse me, less than 185 hours. This is what this question is asking right here. Okay, that's my first question, and I just answered it, 69.15%. Now the other one, what's the percentage or the probability that the battery will last at least? Okay, that's greater than or equal to, so greater than or equal to 185 hours. What's that? These are the questions. I give you words, but that's how it is in symbols. Okay, so how do you find that? Well, you simply subtract it from 100%. So when you're trying to find the percentage of something that lasts longer than something, greater than or something, greater than or equal to in this case, you're going to take 100% minus your answer from the previous one, all right, and get a result. So let's do that. Let's take 100 here, and then, well, not 1,000, but 100 minus 69.15. Okay, 30.85%. So 30.85%. And again, don't get lazy here. Put percentage signs on, do the whole thing. And again, learn how to interpret the words to symbols. Okay, so words, all right, to symbols. You have to know both. Okay, it's just the way it is. If you want to get better and you want to be able to apply what you've learned, practice correctly and write the symbols as well, not just the answers. Okay, some of you guys just write the answers. Okay, write the symbols as well. P stands for percentage, for example. Okay, and X stands for, in this case, a battery. We're talking about batteries in this context. Okay, that's the first one here. Now the next one. Sporting goods store sells 9 brand of hockey sticks. 5 will randomly be put on sale this week. Okay, so 5 out of 9. If one of the 5 must be West brand, how many different combinations of 4 must be put on sale? Well, let me see. You got 5 positions on the sale rack. Okay, so let's say that this is your sale rack. And you got 9 brands total right there, and 5 must be chosen. It kind of sounds like 9 choose 5, but you got to be careful here. One of the 5 must be West brand. So let's say I put West brand right there. Okay. Now I need to choose 4. All right. From not 9, we took 1 out of the 9 out. Okay, we took West out, West brand. We put it on sale rack. Now we're choosing 4 from 8. Okay, obviously 9 minus 1 is 8. So we have 4 more to choose from, but we only have 8 left to choose from. So instead of 9 choose 5, like some people think, it's actually 8 choose 4. So 8 choose 4. Well, the thing that you have to know is your combination theorem. So let's talk about that. So let's see here. So N choose R. So let me go back to basics here. So let's take the formula here. Let's put this in red. So N choose R is N factorial divided by R factorial times N minus R factorial. And I'm not going to go into a full explanation of what factorials are. If you can't remember that, then you have some major studying to do, because I discussed that over many days in class, and I'm not going to go over that again. But you do have to apply the formula. But it's important that you know what a factorial is, because if you can't, well, guess what? You can't do it unless you know how to use it on the calculator, which you can figure that out too as well. So here we have 8 factorial divided by 4 factorial times 8 minus 4 factorial. Okay, so you have N is 8, R, you're choosing R, 4 from 8. So there we go. Okay, now we're going to simplify it a little bit. So 8 factorial on top, 4 factorial down below. 8 minus 4 is usually 4. So I'm going to expand one of the factorials. These are the same down in the denominator, so I'm going to expand one of them. Okay, so we have the first one is, actually, hang on. I'm going to expand the numerator, actually. 2 down to 4. So times 8 times 7 times 6 times 5 times 4 factorial. I'm going to leave one of the factorials here, the second one. Okay, right there. I'm just going to leave it as 4 factorial. But I'm going to expand this one here, 4 times 3 times 2 times 1. Okay, so I just expanded one of the factorials. That's what 4 factorial means. It means 4 times 3 times 2 times 1. And then I just start simplifying, right? So let's start simplifying. Let me see. 2 times 4 is, well, 4 into 8 is 2. 2 into 2 is 1. Okay, now simplifying a little bit more. So 3 into 6 is 2, or 6 divided by 3 is 2. And these factorials cancel, right? 4 factorial divided by itself is 1. And then what do we have left over? Okay, so we have 7 times 2 times 5. 7 times 2 times 5, that's 7 times 10, and that's 70. So there's 70 different ways you can organize this on a cell rack. Okay, and that's all there is to it. There are ways to do it in Desmos, by the way. If you look at, let's see here. Well, I won't go over that. So that's how you do it by hand, guys. Okay, number 3. Let's continue going here. Local YMCA is looking for to get feedback on the swim program from 400 people. There's your total. So what I do is I write down the important things here. So the total is 400 people. Always write down what you know. All right, who are enrolled in swimming lessons. In the school, there's 24% elementary, 36% teenagers, and so on, 40% adults. They take a stratified random sample, which means a sample with the same percentages. Okay, so this term, you have to know what it means. Okay, a stratified random sample is a sample with the same percentage breakdown. So let me just put that down. So the sample has the same, keyword same, percentage breakdown as the original. okay, or as the whole group, okay, as the whole group, which in this case is the YMCA. Okay, there are 70 swimming students. Okay, the sample contains 70. There's 70 in the sample, and they want the sample to have the same, look at the same percentage breakdown. That's what a stratified random sample is all about. How many elementary age students are there? Well, okay, let's do that. So there's 24% elementary in the school, so 24% of 70 is the same thing as 0.24 times 70. And all you do is type that in, guys. I mean, it's not that hard. Okay, 16.8, which is approximately 17 students. Okay, elementary, so you label it. Okay, next one, how many adults? Well, it says 40% adults. So 40% of 70 is 0.4 times 70. It should be 28. So 0.4 times 70. Oops, you gotta. So 0.4 times 70, sorry, 28. So 28 what? Well, 28 adults, right? Well, that's all there is to it, guys. Nothing really hard here. All right, number 4. Apple sells cell phone charging cables to retailers for $18.50 each. Okay, Best Buy marks them up. What's retail price? Well, the first thing you need to know is that retail equals wholesale, all right, plus markup. And these are things that you should know. Okay, all right. The wholesale, well, guess what? That's $18.50 each, right? And the markup is $6.25. And you add the two. So here we go. So you take $18.50, just dealing with money here. When I add $6.25, all right, 18 is 6.24, 50 and 25 is 75, so $24.75. Okay, what's the percent markup? Well, percent markup. What is that? Well, let me see. They want to mark it up 6.25, so you take the markup, okay, the markup divided by the wholesale price, and then you multiply that by 100. Okay, so you take $6.25 divided by the wholesale price of $18.50, multiply that by 100. So here we go. Let's do it. So 625 divided by 1850. All right. And then that gives you a decimal. So you multiply that decimal by 100, you get your percentage. All right. So 33.78. So 0.78% markup. All right. Number 5. All right. The following graph shows supply and demand. Okay, so we got the supply curve here. All right, you've got your demand curve here. You've got your price axis here in dollars. Let's blow this up here. So this is 0, 2, 4, 6, 8, 10. And then you've got, this one's 200. I'm just making these a little bit easier to see. 400 here and 500. And it says, what's the equilibrium price? Okay, well, we don't mark the left-hand side. All right, we mark the other side. So equilibrium is where they intersect. So equilibrium, okay, is the intersection or demand, oops, not B, but D, demand equals supply, okay? Where can you get that? That tells you that you're looking at the intersection point. If they're two equal, then you look for the intersection point. Okay, so then you look at the intersection point and notice they intersect at where the price is 4. Okay, so the intersection, the price here, the equilibrium price, all right, is equal to $4. It's where they intersect. Now, if the price is set at $6, what's going to be greater, supply or demand, and what's the impact on price? Okay, So what you do, and I'm going to mark the diagram just to illustrate because I'm teaching here, but do not mark the diagram on your paper because you're supposed to leave the question unmarked, right? You're supposed to do all your work on the other side. So just keep that in mind, okay? Because you don't want to look at the answers when you want to read the questions, not the answers. So all the answers go on the other side. But I'm teaching, so I'm going to take a look at 6, and I just go straight up. Now look at points A and B. So notice that if the price is set at $6, okay? If the price is set at $6, that tells me that supply is going to be greater than demand. So supply is greater than, well, let's just use mathematical symbols here. Supply is greater than demand. Also, what's the impact on price? So if that's the case, if supply is greater, that means you have a surplus. Okay, now if you have a surplus, that means too much inventory. Too much inventory. What's going to happen is it forces the price back down. So this forces, all right, the price back down to equilibrium, down towards equilibrium. Okay, that's what happens. Now, if the price is set at $2, okay, so let's change it right here. If the price is set at $2, then you got to look at points C and D. And notice that C is above D. That means demand is greater than the supply. So if the price is set too low, okay, what's going to happen is that you're going to have a shortage, okay? So demand is greater than supply. There's not enough, okay? There is a shortage. What's going to happen? It's going to force the price back up. Forces price back up, okay, towards equilibrium. That's what happens, okay? Now, in reality, guys, when you're studying, you do not put the answers on the left-hand side, so just be careful of that. You put everything on the right because you're going to actually practice and study over a period of time. Okay. All right. Next one here. Number 6, a manufacturer takes a poll of several different retailers to determine how many widgets they will buy at different wholesale prices. So you've got the price here, okay, the X values. You got the quantity here, which is going to be your Y values, right? And you need to find the demand function, okay? Now, the demand function in Desmos here, as you guys know, is Y1 tilde mx1 plus b. It's your slope-intercept form, where m is your slope, b is your y-intercept. This is all stuff from Algebra 1. Okay, once we get it, we're going to round to the nearest integer or whole number, and then we're going to use the demand function. Okay, so we need our data in, so go ahead and click on the plus sign, and let's go to work. Okay, so I'm going to enlarge the table. Here we go. Let's put in some x values first. I'm going to delete these just for, you don't delete any of your work. I'm just doing this because I'm teaching so you can see the screen better. Okay, so 21, 26, 29, 32. Okay, just type your numbers in, 34, 36, and then 38. All right, now the quantities, 4,200, 3,650, 3,300, 2,750, 2,200, 2,050. Be careful, I almost made a mistake there. 1,900. Okay, click on this little symbol here underneath your table. There's a little symbol. Click on it. It adjusts the scale for you. Okay, and there are your points, right? So now this is where you get your demand function. You type in y1, okay, y1 tilde now. Use your tilde, mx1, all right, plus b. So you have to use your keyboard. And then you've got your equation. And now let's write the equation. You got your values here. Notice M and B here. You just type them in. So type in y equals, notice I said equals there, negative 146 rounded. So I said round your regression equation to the nearest integer whole number. Okay, round. It's 0.04, so we round down. And then times x, all right, plus the y-intercept, 7,370. All right, 0.67, so we round up. So I'm going to change it to 1. Okay, and there's your demand function. So let's write that down. So now I have my demand function. So y is equal to, here we go, negative 146 times x plus 7,361. Okay, now we have to use the demand function to predict how many widgets Realtor would buy at a price at $33. Okay, so P is $33. That's an X value, so X is 33. So here we go. So we type in negative 146 times 33, all right, plus 7361, all right, and there's how many widgets, right? 2,543 widgets. So here we go. So y is equal to negative 146 times 33 plus 7,361. So I've got, okay, oh, I didn't. So 2,500 here, 2,543. 2,543 widgets. All right, and we're rocking and rolling. There we go, my friends. All right, and you obviously have to write small on this document here so you can, keep everything in the correct correct location here on your study sheet, which is called practice questions. All right, you're designing your own practice questions. All right, number 7. Let's keep it rocking and rolling, as they say. So we got this expense function here. Find the total expenses for producing 18,000 bags of dog food for this company, dog food company. So here, Q, the quantity is 18,000. My expense function is 32 times Q plus 118,000. So it says find the expense, right? Let's find it. So 32 times 18,000 times 118,000 or plus 118,000. So you just type it in, guys. So 32 times 18,000 plus 118,000. Okay, and you get your total expenses. That's a lot of money because this is a business, right? 694,000. There we go. That's my total expenses. Okay, now what's the average? Well, you need a method, right? So the average cost here is always equal to total expenses. Notice how I'm putting this in red. All right, to divide it by the quantity. Now, if you don't know that, well, there's a problem right there. You just found something you don't know, and you have to know these basic things, and that's why you have to practice. Now, you can't apply what you don't know. So the average cost is going to be, here we go. So 32 times 18,000, right, plus 118,000. Okay, and that's obviously 694,000 divided by 18,000, right? The quantity. So you could type that whole thing in. You don't have to step it out in two different steps. What you could do is type in 32 times 18,000 plus 118,000 divided by the quantity, which is 18,000. All right, and there you go. All right, so the unit cost is 32 bucks, but the average cost when you factor in the fixed expenses is $38.56. Notice I rounded there too, okay? Round to the nearest penny, always. So up here, just so you guys understand what's going on here, the unit cost is $32 per widget. That's what it costs to produce. Okay, without taking into account the fixed expenses. The fixed expenses in a business are huge. And in this case, in this business, it's $118,000. That might be the machinery, the building, okay, everything it takes to produce a widget, right? When you factor that in, it's going to raise the unit cost up. And if you produce enough widgets, like 18,000 or more, it's gonna give you an average cost of $38.56. The more you uh, produce this, the less the average cost. Okay, we talked about that in class. Okay, number 8. All right, we're doing well here. Find the quantity at the break-even point. Well, you have to know what break-even means. So break-even means something very important. There's a very special point. Break-even means that revenue, all right, equals expense. All right, and if I give you the revenue and expense functions, all you do is set them equal to each other and solve for Q. It says find the quantity Q. Q equals question mark. Well, they're equal, guys. So $5.80 times Q plus 260,000. That's got to be equal to the revenue of 16Q. Okay, now solve the equation. So let's subtract 5.8Q on both sides. Then what do we get? We get 260,000 on the left. If you don't know what 16 minus 5.8 is, you type it in. If you can't handle it in your head. So 16 minus 5.8, all right, 10.2, so 10.2Q. Then last step, divide by 10.2. And you get Q. The quantity here is equal to something. So you take 260,000, all right, divided by 10.2. You get about 25,490. And you round, okay? Widgets. All right, we're dealing with physical things, so you obviously have to round. All right, number 8, Wexler's widgets, manufacturers widgets. Okay, they create a monthly expense equation of all the expenses in 1 month of manufacturing. Here we go. So we're given this expense equation. They plan to sell the widgets to retailers for a wholesale price. We're given this wholesale price right through here. So I would write this down over here. So when you're working on a problem, always write down, what you are given. I'm given the expense equation. Okay, that's obvious. It's right here. I've given the wholesale price. So always write down what you know. This is the price where they sell it to retailers, like Best Buy if it's electronic or something like that. It could be Walmart, Target, who knows, right? It could be Costco. And it says what is their total expenses if the company makes 1,000 widgets. Okay, so Q equals 1,000, right? 1,000 widgets. So you write down what you're given. I'm given 1,000 widgets, trying to find the expense. Well, just substitute it in. That's all you do. So what is the total expenses? Well, 1.6 times 1,000, right? Plus 8,500. 10,100. There's your total expenses. What's the total revenue? Well, revenue, okay, that's price times quantity. So wholesale price times quantity. Now, some of you guys write down P times Q. Okay, that's fine, but you better know what that means. Okay, so $3.75 times 1,000. And you just have to shift the decimal, but if you can't do that in your head, Well, type it out, I suppose. Okay, so 3.75 times 1,000. Just shift the decimal place 3 places right. Okay, and you get 3750. There's your revenue. Okay, so we have the expenses, we have a revenue. Okay, if the company sells 1,000 widgets, will they lose or gain income? Well, you always take revenue minus expenses, just profit. Okay, which is when you're making money, is always found by taking revenue minus expense. So the money coming in is 3750. The money going out is 10,000. Oof. Hmm. $10,100. Like how this is a bad situation. So 3750 minus 10,100. Okay, that's negative 6,350 bucks. All right, this is a loss, right? If you're not bringing enough money in, okay, so this is money in and this expenses is money out. If you're not bringing enough money in and you're spending more than you're making, you're going to be losing money. So it's a loss. Okay. All right, and that's number 8. Number 9, oh boy, here we go. So given the expense and revenue functions, what price yields maximum revenue? Well, this is a heavy calculator-based problem here, so I'm going to enter in some functions. I'm going to turn off the previous one. So if you have functions on, turn off the colors. Do not delete them. Okay, just turn off the colors. Be smart about it because you don't want to delete your work. Oops, I didn't mean to do that. Let's type in our expense function. So to do that, you have to kind of translate these things. So this one here, your expense function in terms of x and y looks like this. Y is equal to negative 1,100 x plus 40,000. And your revenue function looks like y is equal to negative 150 p squared plus 3,800x. I didn't mean p, I meant x right there. So let's type these in. Okay, so y is equal to negative 1,100 x plus 40,000. Next one, y is equal to negative 150 x squared plus 3,800x. Oops, see, I made a mistake right there. 3,800x. So you got to check your values. Okay, I'm talking about these two here. So make sure we typed them in correctly. Oh, I missed one. See, look at that. It's good. This is good that I'm checking, right? Okay. So you have to be good at the iPad right there. And we need to zoom in here. Ooh, holy cow, this is weird. Look at this. Hmm. Are there 2 intersection points? There are 2 intersection points. Wow, they're really close together here too. That is wild. But we're not looking for the break-even points. We're looking for the maximum revenue, which is at the top of the revenue function. Okay, so the price that yields the maximum revenue, this one here. So the price is at the maximum. It's at the vertex. Okay, where the max is located at. And if you read this right through here, it's $12.67. Okay, it says estimate the maximum revenue. Well, that's the y coordinate. So this is the x coordinate. The max revenue is the y coordinate, and you just read it up here. It's 24,000, all right, $66.67. So notice that I'm rounding to the nearest hundredth every single time. Okay, and which one is the leftmost break-even point? Well, let's take a look at. Let's zoom in here. The line intersects the, excuse me, where the revenue meets the expense. It intersects 2 different places, and the one on the left is 16, 22,400. So this one here is 16 comma 2200 or 22,400. So if the price is set at $16, the revenue here would be 22,400. And it says, what's the profit function? Well, we got to figure that out. Okay, now we got to do some work here first. Okie dokie. So what we want to do is say profit equals revenue minus expense. And let me see, this right here is negative. Well, you start with the revenue function, so negative 150 p squared plus 3800 p minus, right, minus the expense function, negative 1100 p plus 40,000. Okay, so let's distribute through the minus sign twice and be careful. So capital P for profit, negative 150 p squared plus 3800 p plus, there's a double negative there, 1100 p, and then minus 40,000. And then you collect like terms, and you get the profit is equal to negative 150 p squared, 3800 and 1100, that's 4900 p minus, excuse me, so minus 40,000. Okay, so now we have everything here. So now what we do is we type this function in. So I'm going to type the profit function in. So y is equal to negative 150 x squared plus 4900 x minus 40,000. Now I'm going to go full screen so you can see this better. Okay. It barely, look at this, it barely is above the x-axis here. See? There we go. And there's not much profit. Holy cow. So I can see my roots right here. Those are the roots, but I don't need those. Here I need the profit. So the price there is $16.33, and the profit is only $16.67. Holy cow. Let's go back to the lesson here. Okay, so find the maximum profit. So max profit is equal to, right, the y coordinate, $16.67, okay, if the price is at $16.33, okay? So this is a y value and this is the x value. There we go. Make sure you save your work right there. All right, and now, guess what? We only have one more to do. Okay, so let's do it. We're given this profit function here, and let's turn off the previous ones, and let's take a look at this new one here. Let's type it in and see what the maximum profit is. So real easy. Y is equal to negative 370, all right, x squared plus 8800x, right, minus 25,000. So you type your function in. I'm going to go full screen so we can see things better. There's my parabola. Okay, now there's my profit function. So if we set the price to $11.89, we're going to get a maximum profit of over 27,000. Okay, so let's write down what we have. Okay, now it says price at max profit. So okay, so the price is your x coordinate. So if the price is $11.89, the max profit, which is the y value, is 27,324 dollars and there's a comma right there and 32 cents. There we go. And there it is, my friends. All of them. This is what you've been studying throughout the entire unit. All you have to do now is go one step further. You have to practice daily. Okay, so a couple points. Key things to success. This is the first step. Okay, step number one, we filled out the answers. Okay, big deal. Okay, so step number one. Okay, okay, we solved all the problems. Solve all practice problems. We did that. But believe it or not, that's not enough. You're not going to be able to do this easily. All right, I can prove that any day of the week. Okay, step number two, you got to practice all of these. Okay, practice. Okay, again. Okay, daily. Okay, and keep track of the ones you don't know and you separate them into groups. Okay, you have to know what you know and what you don't know. All right, and then three, okay, space repetition. Space repetition, which means you got to repeat it, but spaced out over a period of days. Repetition, okay, over 5 to 7 days. And there we go. And if you do that, if you go through all of these questions, fold it in half, get another piece of paper out, and actually practice again daily over 5 to 7 days, I can guarantee you that you're going to get better, but you're going to also get faster. And I'm also guarantee you that you guys are going to be doing really well the next time around. If, however, you skip steps 2 and 3 and don't practice and don't space it out over 5 to 7 days, and you skip steps 2 and 3, well, don't don't come in and try the test. Okay, you'd be wasting your time, and you're wasting my time. All right, you got to do steps 2 and 3, and that's what a lot of people don't do, and that's why we don't have a whole lot of A's. All right, well, actually we do, but we would have more A's. We'd have the whole classroom, of students getting more A's because you guys have to learn how to practice effectively and efficiently and do it the right way. So do something new, do something better the second time around, and then make yourself proud. And I'll see you on retake day. All right, this is Ainsworth. You guys take care. Bye bye.